In the heart of Alaska, a sleeping giant stirs. Mount Spurr, a stratovolcano slumbering 75 miles west of Anchorage, is exhibiting signs of unrest. Scientists at the Alaska Volcano Observatory are closely monitoring the volcano for an increased likelihood of eruption. They're observing a symphony of activity hinting at the forces brewing beneath the surface. Hundreds of small earthquakes have been recorded in recent months, a telltale sign of magma movement within the volcano's plumbing. These earthquakes, although small in magnitude, indicate that molten rock is forcing its way upwards, putting pressure on the surrounding rock. The ground around Mount Spurr is also deforming, subtly rising and shifting as magma pushes upward. This deformation, measured by sensitive instruments, provides further evidence that Mount Spurr is becoming restless. Adding to the concern, scientists have detected the formation of a crater lake at the volcano's summit. This lake, filled with warm water and emitting gases, suggests that heat is building up below. The gases bubbling to the surface, including sulfur dioxide, are a tangible reminder of the volatile forces at play within the volcano. These observations taken together point to a heightened state of unrest at Mount Spurr. The sleeping giant is showing signs of awakening, and scientists are watching closely for any indication of an impending eruption. The question is not if, but when Mount Spurr will once again unleash its fiery fury. Predicting volcanic eruptions is a complex and challenging endeavor. It's like trying to forecast the weather, but with far fewer data points and a much more volatile subject. Despite these challenges, scientists are working diligently to assess the likelihood and potential timing of a Mount Spurr eruption. Based on the current level of activity, experts estimate there is a 50% chance of an eruption in the foreseeable future. This estimate, however, comes with a significant degree of uncertainty. The exact timing of an eruption, whether it be days, weeks, or even months away, remains elusive. Volcanoes operate on their own timescale, and Mount Spurr is no exception. Scientists are closely monitoring key indicators that could provide further clues about the timing of an eruption. A rapid increase in the temperature of the crater lake water, for example, could signal that magma is nearing the surface and an eruption is imminent. Similarly, accelerated melting of the snow and glaciers on the volcano's slopes could indicate rising heat flow and an increased likelihood of an eruption. While predicting the exact timing of a volcanic eruption remains an inexact science, scientists are constantly refining their models and monitoring techniques. The goal is to provide as much advance warning as possible to communities that may be in harm's way. A volcanic eruption is a spectacular display of nature's raw power, but it also poses significant hazards to people and infrastructure. In the case of Mount Spurr, the primary concerns are ash clouds, ash fall, and other volcanic hazards. Ash clouds, composed of fine particles of volcanic rock and glass, can rise tens of thousands of feet into the atmosphere, posing a serious threat to aviation. These clouds can travel thousands of miles, disrupting air travel and grounding flights. Ash fall, the deposition of ash on the ground, can also have widespread impacts. Even a thin layer of ash can disrupt transportation, damage crops, contaminate water supplies, and cause respiratory problems. In the event of a significant eruption at Mount Spurr, Anchorage, with a population of nearly 300,000, could be blanketed in ash. While ash clouds and ash fall pose the most widespread risks, other volcanic hazards are also a concern. Pyroclastic flows, fast-moving avalanches of hot gas and volcanic debris, could occur on the slopes of Mount Spurr. These flows are extremely dangerous and could travel several miles from the volcano's summit. Mud flows, also known as lahars, are another potential hazard. These flows, a mixture of water, ash, and debris, can be triggered by eruptions or heavy rainfall on the volcano's slopes. Mud flows can travel long distances, often following river valleys, and can cause significant damage to infrastructure. Mount Spurr has a history of eruptions, reminding us that its current unrest is not an isolated event. The volcano last erupted in 1992, sending ash clouds high into the atmosphere and disrupting air travel for hundreds of miles. The 1992 eruption, while significant, paled in comparison to the volcano's 1953 eruption. The 1953 eruption was a major event, sending ash columns towering 65,000 feet into the atmosphere. Ash from the eruption fell as far away as Anchorage, coating the city in a layer of fine grey powder. The 1953 eruption serves as a stark reminder of Mount Spurr's potential to disrupt life in Alaska. Scientists studying the volcano's eruptive history believe that a new eruption is most likely to occur at Crater Peak. This peak, located within the volcano's summit caldera, has been the site of past eruptions and is showing signs of unrest. The summit of Mount Spurr, while not active in thousands of years, could also be a potential eruption site. Understanding Mount Spurr's past eruptions is crucial for predicting the volcano's future behavior. By studying the frequency, magnitude, and location of past eruptions, scientists can better assess the hazards posed by a future eruption and provide timely warnings to communities at risk. The history of Mount Spurr is a reminder that we live in a dynamic world shaped by powerful forces that demand our respect and attention.